Namaste everyone, welcome to the physics class. We were in the 10th problem in the last class that was related to energy. We were not able to use the formula V square is equal to V naught square plus 2AX, right? Namaste, welcome to the class. So this problem needs a law of conservation of energy, total energy on the surface, total energy at a point are one and the same. Now actually I should have completed another problem along with that is the next one which is related to electric field and potential, right? It is the total energy of the charged particle is same. So here is the problem. An electron is projected with an initial velocity with the initial speed of 3.2 into 10 to the power 5 meters per second directly towards a proton. So proton will attract it, right? So an electron is projected towards a proton, okay? So this is electron, this is proton, okay? That is fixed in a place. If the electron is initially at a great distance from the proton, so that velocity is at a very large distance, 3 to 10 to the power 3.2 into 10 to the power 5 meters per second. At what distance from the proton is the speed of the electron instantaneously equal to twice the velocity initial value. Whatever this velocity is here, that velocity should become double, right? That means twice means it becomes some 6.4 into 10 to the power 5, or I will write 2 into 3.2 itself, so that it becomes easy for the calculation. 3.2 into 10 to the power 5 meters per second. This should be the velocity by the time it reaches here. At what distance from the proton, right? This is electron actually. This is electron moving towards the proton. So at what distance from the proton, the instantaneous velocity will be double the initial velocity. Because it keeps on, that proton keeps on attracting the electron, so velocity will go on increasing as it approaches towards the proton. Now here also you have to apply the law of conservation of energy. The total energy here, I'll name this as A and this as B. Total energy, kinetic energy plus potential energy at A must be equal to kinetic energy plus potential energy at B. Of course, this distance is very large, they have mentioned. At a very large distance, it is, so potential energy can be taken to be 0, because potential energy is given by 1 by 4 pi epsilon naught Q1 Q2 by R, because it is electrostatic potential energy. So this problem goes very similar to that previous one, where the potential energy was minus Gmm by R. Here G, in the place of G we have 1 by 4 pi epsilon naught Q1 Q2 by R. So shall we write the formula? Kinetic energy half mass of the electron, you would write. Mass of the electron is 9.1 into 10 to the power minus 31 kg. V square, that is 3.2 into 10 to the power 5 whole square, plus potential energy. Potential energy is it is negative because it is attractive. So shall I write it as minus 1 by 4 pi epsilon naught, this one Q1 Q2. The charges of electron and proton are same, 1.6 into 1.6 into 10 to the power minus 19 minus 38 coulombs. Coulomb square actually. 1.6 into 10 to the power minus 19, 1.6 into 10 to the power minus 19 divided by distance. Distance, of course, this is 0. Why? Because it is at a very large distance. I need not have to write this, minus 0. Potential energy here is 0 because it is at a very large distance. R becomes infinity, so that becomes 0. That is equal to kinetic energy plus potential energy at B. At B you have both. What is the kinetic energy? Half m 10 to the power minus 31. V square is 3 double this velocity, 2 into 3.2 into 10 to the power 5 whole square, plus potential energy. Potential energy, now there is potential energy, 1 by 4 pi epsilon naught Q1 Q2 into 10 to the power minus 38 19 divided by distance, don't know. So 1 by 4 pi epsilon Q1 Q2, okay, then again minus. Why? Because one is proton, one is another one is electron, and the force is automatically it is attractive and it is the negative potential. right? Negative potential energy. So minus 1 by 4 pi epsilon naught q1 q2 by distance. X is the unknown factor. This is not a very tough problem. Even mathematical part here involved is very easy. What you have to do is, you see this is 2 times than this one, right? So when you square this, it becomes 4 times. So minus this one, correct? So I can bring this part here. What I can do is, I can write the common things, that is 9.1 into 10 to the power minus 31 into 3.2, shall I write it a little bit below? 9.1 into 10 to the power minus 31, this one, into 3.2 into 3.2 into 10 to the power 10, correct? Hope you are following this one. I write this 9.1 into 10 to the power minus 31, 3.2 into 3.2 into 10 to the power 5 to the power 2, that is 10 to the power 10, okay, 10 to the power 10 divided by 2. This much is common here and here. Only the thing here is 1 minus, this is 2 square, 4. That's the only thing you have extra. That is equal to the remaining part there. That is equal to minus 9 into 10 to the power 9, 1.6 into 1.6 into 10 to the power minus 38 divided by x. I have brought the whole term here, which has got an extra 2 square, that's all. Everything is here, right? Except 2 square here, everything is here. So you can write that common, and you can write 1 minus 4, because here is a 2 square and everything else is written. Now, can I write this as minus 3, and can I divide this 9.1 and 9 times? I will approximately cancel it. There is no problem in this. And what else? See, 1.6 2 times 3.2, and this 1.6 2 times 3.2. Okay. Then what else? I want to draw x. I have to bring x here and remaining part here, and this is minus 3. Correct? Shall I write it here now? I will rub this one. Okay. I'll rub this part and I'll write the remaining here. So x I will bring it here. X is equal, this is not difficult, it's a very easy problem actually. 2 here, and minus minus I can cancel, and here minus I have minus 3, minus minus I can cancel. So 2 into 10 to the power minus 38. That is the only thing that remains in the numerator. Of course, x here. Then here what do you have? Minus 3 into 2 into 2. How much it is? 12. Correct? 2 into 2, 4. 4 into 3, 12. And what about 10 to the power? Minus 21. Is it okay? Anything else remaining? Minus 21. Okay. 10 to the power minus 31. And this is 2 2s are 4. 4 3s are 12. Yeah. Okay, that's right. Minus 31. This is 3.2 into 3.2 into 10 to the power 10, because velocity is 3.2 into 10 to the power 5. This is minus 38. Minus 38 comes to there only, and x comes here, 2 goes here, and minus 21 comes here. Okay, so that is equal to, because you don't have 10 to the powers here, I think I have left with some 10 to the powers, 9.1 into 10 to the power minus 31. Velocity square, there, where is the velocity square? Okay, that I have brought this side, and 9 into 10 to the power 9 I have, yes, that I have not written, 10 to the power 9, yes, because we don't have 10 to the power more than 10 there, so that's what I was searching. So that is x, finish, by 6, and 0.1666 into 10 to the power, this is minus 29, correct? Minus 29 plus 21. Minus 9 plus 21, minus 8, correct? Minus 29, 38, so this is minus 21 plus 21, minus 8, that is equal to, you have all 1.6, 10 to the power minus 9, yeah, this is the answer. So you should have a little bit of patience, that's all. With lot of patience you have to do this, and all these things may go along in the full page, but they are not tough questions, tough calculations. See, within a second step it gets minimized, because you have 2 times here, so you can bring it to the left hand side and you can solve it. So option 1. We will go to the next one, 12th one. A body of mass m is raised through a distance equal to radius of the earth. From the earth's surface, the change in potential energy. Very similar problem once again. A body of mass m is raised through a distance equal to radius of the earth from the earth's surface. Change in its potential energy is, yes. Now when the body is on the surface of the earth, so delta U I have to calculate. When it is on the surface of the earth, what is the potential energy? Minus G m, right, in a body of mass m, radius. And when it is raised to a height which is equal to the radius of the earth, then the new, so this is the distance from the center, right, r. When you raise it through a distance r again, you will have minus, difference I want to calculate, minus change in potential energy, minus of minus G m by r plus r, 2r, because now the distance is 2r. Everything else has remained the same. Its mass and the mass of the earth, that remains the same. Only the distance increases. So the change delta U is equal to minus Gm by r into 1, and this becomes plus, minus of minus, it is 1 minus 1 by 2, correct? No, it is minus Gm by r. If I take it outside, 1 minus half, this is half, minus Gm by r, 2r, this is the answer, minus Gm by 2r. Okay, they want to put it in the form of acceleration due to gravity, multiply and divide by r, what you will get? Minus, of course, they want the change in positive sign, that means you have to subtract this from this, you will get positive, that's all. They want the change higher minus lower. So I should have written this first and this next. Okay, whatever it is, you just delete the negative sign, delta U, change in the potential energy, then minus G m r by 2 r squared, and Gm by r squared, this much, Gm by r squared, that is acceleration due to gravity, delta U, change in the energy, minus Gm r divided by 2, minus Gmr by 2, mrg by 2. This is the answer, right? Of course it is positive because we want to find out the change. So the energy on the surface and energy at that point, take the difference. A planet of mass m is placed inside a spherical shell of radius r and mass m at a distance r by 2 from the center of the shell. The gravitational force exerted by the shell on the mass is, you know that the acceleration due to gravity or the gravitational force inside a shell, electric field inside a spherical shell is 0. Similarly, acceleration due to gravity inside the shell is 0. There is no gravitational field inside a shell, not I am saying inside the earth. Inside the earth there is a gravitational force, because when you go inside the earth to this much amount, there is this much amount of earth which is attracting the body towards its center. Okay, there is a force on the earth. But on the ball of mass m, say, when it is kept, this much of earth is exerting the force. But if it is a spherical shell and empty inside, there is no force. So a planet of mass m is placed inside a spherical shell of radius r, and mass m at a distance equal to r by 2. R by 2 means it lies inside the shell. The gravitational force exerted is 0. There is no force on the that planet which is kept inside the shell. 14. A planet moves around the sun. At a point A, it is closest from the sun. The sun is at a distance d1 and has a speed v1. Closest from the sun, yes. That is conservation of momentum, law of areas. The line drawn from the sun to the planet sweeps out equal areas in equal intervals of time. Say this is the closest part, right? At a point A, closest to the sun, and distance d1 and speed is v1, okay? At the point which is farthest from the sun, the distance is d2 and velocity will be v2, and what you have to do is the conservation of angular momentum, mvr, mass of the satellite, and velocity or planet, mv1 d1 is equal to mv2 d2. They want v2, correct? Its speed will be v2. M gets cancelled. v1 d1 divided by v2 gives, by d2 gives v2. V1 d1 divided by d2, option 1. V1 d1 divided by V2 mvr, so that is a conservation of angular momentum, option 1. 15. The escape velocity from the earth is 11.2 kilometers per second. If a body is to be projected in a direction making an angle 45 degree to the vertical, then the escape velocity is. Escape velocity doesn't depend on the direction along which you are throwing, whether you are throwing like this or like this or like this. Escape velocity is same everywhere. It doesn't depend on the direction because it comes from the law of conservation of energy. Work done in taking a body from that position to that position, irrespective of the path. So it is 11.2 kilometers per second only, no change. 16. Two planets have masses in the ratio 1:2 and radii in the ratio 2:3. The ratio of acceleration due to gravity. What is the formula for acceleration due to gravity? Gm by r square. Mass of the planet by radius of the square of the radius of the planet. Gm by r square. So G1 by G2 have masses in the ratio 1:2. Same ratio. And radii in the ratio 2:3. 2 square is to 3 square. Radius comes in the denominator. What is the acceleration due to gravity ratio? 9 by, this is 8. Right? 9 by 8, first option. Right? We have 8:9 also. Masses in the ratio 1:2 and 2 square, 3 square by 2 square, 9 by 8. Yes. The change in the value of G. The change in the value of acceleration due to gravity at a height h above the surface of the earth is same as at a depth x below it. Yes. At a depth below, as you go deep into the earth, acceleration due to gravity decreases. As you go above the earth, it decreases. They say that from the surface at a height h and at a depth x, they are equal. So you know that G at a height h is G into 1 minus 2h by r. And G at a depth x, say, G into 1 minus 1 minus x by r. No 2 here. They are same. H and x are much smaller than the radius. Then you can use this formula. If height is very large, then you can write r by r plus h whole square. Okay, now if they are equal, then G into 1 minus 2h by r must be equal to G into 1 minus x by r. G gets cancelled. 1 also gets cancelled. 2h by r minus also gets cancelled. 1 minus 2h by r is equal to 1 minus x by r. Yeah, 1 gets cancelled. Minus gets cancelled. X by r. R gets cancelled. 2h by r. 2h by r is equal to x by r. X is equal to 2h. You have? Yes. Very easy problem. A satellite in a circular orbit of radius r has a period of 4 hours. A satellite with the orbit of radius 4r around the same planet will have a period of. Square of the period of revolution is equal to, is proportional to the cube of the mean distance. Square of the period of revolution is proportional to the cube of the mean distance. A satellite in a circular orbit of radius r has a period of 4 hours. 4 square r cube, one equation. A satellite with the orbit of radius 4r has got how much period? T square by 16, divide this. T square by 16 is equal to 4 cube r cube divided by r cube. Right? T square is equal to, this is 4 cube into 16. What is T is equal to? Square root of 4 cube into 16. That is equal to square root of 4 square into 4 into 16. That is equal to, so 16. I have written this one as okay, you could have written it as 64, right? 64 into 16. Then what is the answer? So it is, this is 8 and this is 4, that is 32. So answer is 32 hours. 32 hours. Simple problem, just comparison. A man falls a distance of x in 1 minute near the surface of the earth. That means near means at a certain height where the acceleration due to gravity doesn't change. A man falls a distance of x in x meter in 1 minute near the surface of the earth. How much distance will he cover near the moon surface in the same time, where acceleration due to gravity is 1/6 of that on the earth, right? Acceleration due to gravity on the moon is 1/6 that on the surface of the earth. Now how much distance he will cover in the same time? No, the distance covered is given by x equal to v naught t plus half at squared, assuming g to be constant at that height as it falls, but not on the moon and not on the surface of the earth. Of course, at comparison g is different, but on the surface of the earth at different points it is constant. We have chosen such a height, small height, but for both the things it is dropped. This part is 0. So x is equal to half gt square. That is what we get. And time is not in the competition, because in the same time we have to compare how much distance that object will fall on the surface of the earth as well as on the moon. So x is proportional to g. If g is g/6 on the moon, x is x/6. Same answer, right? It is no difference. x/6. At what height over the earth's pole acceleration due to gravity is reduced by 10%? That means you have to take 90%. Whatever you have the acceleration due to gravity on the surface of the earth, it is taken as 100%. Whatever you have to calculate on at that point, it should be taken as 90%. 90/100 is 0.9. 100/100 is 1. So at what height over the earth's pole so g at height h is equal to g into 1 minus 2h/r. At what height over the earth's pole is acceleration due to gravity is reduced by 10%. That means this is 0.9 g is equal to g. This is 100% g at the surface. This is 10% less. 0.9 g is equal to 1 minus 2h by radius 6400 kilometer. Let it be in kilometer. H will also be in kilometer. All the answers are in kilometers, so don't have any problem. Gg gets cancelled. I will bring this 2h by 6400 here and 1 minus 0.9. Then h by 3200 kilometer is equal to 0.1. So 0.1 into 3200, h is equal to 320 kilometers. Simply raise this. Yeah, this is the answer. The same tick mark can be used. 320 kilometers is the distance at a height where acceleration due to gravity is 10% less than what it is on the surface. Hope we have not gone wrong with any zeros, right? 1 minus 2h/r, 2h by 6400, 3200 into 0.1, that is 320 kilometers. Yes, 21. The escape velocity for a body from the surface of a planet whose mass is 320 times and radius is 20 times that of the earth is. You know, mass and radius you should get. Escape velocity is root of 2rg. Write the value for g, because we want mass and radius into play here. They will come into play. R gm/r square. 1r gets cancelled. Escape velocity is equal to square root of 2gm/r. This is the formula. It is on the planet. This is 11. As usual, it is 11 on the surface of the earth. Surface of a planet whose mass is 320 times and that radius is 20 times. 16. Root of 16 is 4. So it is 4 times that on the surface of the earth. Correct? If it is 4 times that on the surface of the earth, then it should be 44 kilometers per second, not hour. 44 kilometers per second. That should be the escape speed. Kinetic energy of a satellite orbiting close to the earth is, kinetic energy of the satellite orbiting very close to the earth is, that is half m squared. See, what is orbital speed? Root of rg. But there is no acceleration to gravity here, so I have to substitute. You take, or if you remember the formula, then it is well and good. You just compare it with the atoms chapter in the second year, whereas wherein you get kinetic energy and potential energy are related, right? Kinetic energy is half of that potential energy, but potential energy is negative. Total energy is also negative. Similarly here, kinetic energy cannot be negative. So these two answers can never be the answers, right? It is always positive. Now, root of rg, r g m/r square. 1r gets cancelled. Root of gm/r, that is orbital velocity. Now what is kinetic energy? Half m orbital velocity square half m gm by r. Gmm by 2r. Gmm by 2r. This is the kinetic energy, and the potential energy is double this, minus, you see, same as that we have atomic theory, Bohr's atomic theory, minus Gmm by r, no half, it is double this. When you double it, 2 gets cancelled. This is potential energy. Total energy is negative and same as kinetic energy, minus Gmm by 2r. Okay. 23. The value of gravitational constant depends on what factors? Capital G. Remember, capital G is a universal constant. It need not depend on anything. When you write the Newton's law of gravitational force, F formula for the force between two planets like Saturn and Jupiter, Mars and Venus, Earth and Moon, whatever it is, capital G is a constant. It does not depend on anything, so it is none of this. The value of acceleration due to gravity doesn't depend on the masses, distance, both, nothing. Right? Option D. 24. The period of oscillation of a simple pendulum at the center of the earth, T is equal to 2 pi into square root of L by G. G is 0 at the center, no acceleration. As you go deep into the earth, it decreases, and it becomes 0 at the center. If G is 0, period is infinity. What do you mean by period infinity? Once the pendulum, suppose the pendulum is left like this, it doesn't come back at all. To complete one oscillation, it takes infinite time, means it doesn't move at all. Taking infinite time means not moving at all. So infinity. Okay. 25. The atmosphere is held to the earth by, automatically it is gravity, and you know that Earth's gravity pulls the atmosphere and keeps it always intact with the earth. And that's why, since gravity is more on the surface of the earth compared to the acceleration due to gravity on the moon, that air has been always pasted like a blanket to the earth, whereas it is not found in the moon because escape speed is less. So gravity pulls it down, it keeps always around it. So option, this one has to be removed, so that is A. So these are the questions. So in the next class I will give you one question paper. 45 questions, it take 1 hour exactly, write it, and we will discuss it later. So I will do that, such types of question papers, so that it will be useful. Thanks for watching my class. We'll meet in the next class with the test paper. Thank you.